All right, you guys, we want to take some time today to talk about solving logarithmic functions. Yay! All right, you guys, so we learned a lot of different methods for solving this, right? Our first way that we talked about would be graphing our function and using graph trace to find our x-intercept. The second thing we talked about was using our calculator tool in solve. So we can do menu 3, 1, and then type our equation into insolve. So we'll have insolve, and then we'll do our equation here, comma our variable. So we could say comma x, or whatever our variable is, and that will give us our answer. What we really want to spend time doing, though, is thinking about how to do this algebraically. So we have some big exponent rules, right? So log rules. So if we think about our log rules, if I have log of A plus log of B, that really means log of A times B. Similarly, if I have log A minus log B, that means I'm going to have log A divided by B. And finally, if I have a number, so let's say we can call it, let's call it n log of A. I can make this n. I can move it into an exponent, and we'll have log of A to the n power. So these are going to be our tools for solving. Let's start with a basic example. Let's say that I have log base 4 of x is equal to 2. I know I undo a log with an exponential function, so we said my base stays the same. If it's 4, I'm going to big 4 both sides, just like this. So on my left side, this cancels out. I'm going to say x equals 4 squared, which in this case, oh my gosh, holy cow. X equals 4 squared, which means x equals 16. All right, another example. So when we're solving, we always use reverse PEMDAS. So we're going to have PEMDAS backwards, or SADMAP, as some of us might call it. So if I'm doing a second example, let's say we have log base 2 of x minus 3 equals 3. So the first thing I notice is that my log, I'm going to draw my box, or like my group, directly to the left of my L, and then wherever my parentheses ends. I see that my box is alone on the left side of my equal sign, so I know I'm ready to get rid of my log. So we're going to big 2 in this case. I see my base is 2. So we're going to big 2 both sides. On the left side, my log, my base are going to cancel out, and I'll be left with x minus 3 equals, on the right side, 2 cubed. So we'll have 2 cubed. So I know 2 cubed is actually 8, so I'll have x minus 3 equals 8. To finish up, to get my x alone, I'm going to add 3 to both sides. So we're left with x equals 11. All right, you guys, another example. Let's say that I have log of 2 plus log of x equals 16. So I want to come back over to my log rules because I see I have 2 logs. I only want 1. So let's combine them. Since I have a plus in the middle, same base, that means I can, when I have plus, I actually multiply. So I can combine this to say log of 2x equals 16. When I don't have a base, right, since I don't have one here, we said I can assume it's 10. So I'm now ready, since I have my log alone on one side, to get rid of that log, and I'm going to do it by big 10ing it. On the left side, it's going to cancel out, and I'm left with 2x. On the right side, I'm going to have 10 to the 16th power. All right, you guys, total honesty, I do not have a calculator handy, but I'm going to figure that this is 1. Actually, no, this is 1 with 16 zeros left. So we know this is actually 2x equals 1. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I should have chosen a smaller number. All right, in this case, to finish up, I see that I have this 2x. I want x alone. So I need to divide both sides by 2. And the number that I get will be my answer. All right, you guys, these are just a few examples. If you would like more, please come see me. I'd be happy to give them to you. Have a great day.